So in this video, we're going to create the stamp body, and we're going to use Shapr 3D. This isn't going to be a beginner's guide to that software. If this is the first time that you've used Shapr 3D, I strongly suggest you ask your teacher about the pizza cutter tutorial that we created. That goes into step by step about all the functions and settings and the tools and how to better understand what's going on. We're going to go quite quickly into this video, so I'm not going to explain too much about the tools. We're going to get straight into the designing. So looking at the stamp body on the screen here, you can see that it's a cylindrical shape, but there is a space inside, a void, for us to put an M6 nut inside. This will allow us to basically screw in the handle from the stamp handle. I'm going to show you how to do that in Shapr 3D. So let's head over to the iPad now. Okay, so I've just opened up Shapr, and on screen now is what you'd be greeted with when you open the software. We're just going to hit the little plus icon to make a new file, and now we've got our blank space. So going into a top view and getting the access in the middle, we're going to create and hit sketch and then go to circle, and we're going to make the base part of the stamp body. So with regards to my stamp, I know that it's going to be a diameter of 40 millimeters. There we go, and I can see that it's drawn it there. I'm going to hit exit sketching. So the first bottom section is actually this 40 millimeter circle, but extruded by 5 millimeters first. So I'm going to hit the plane, start dragging up and put in 5 millimeters. So I now know that that's 5 millimeters tall. And then with this plane selected, I'm going to hit sketch again, and we're going to draw another circle. I'm just going to close down this tutorial here. From the center, I'm going to drag out basically the top diameter, the top circle, and I know that's going to be 24 millimeters, and that's a 24 millimeter circle. At the moment, that's placed it just on the top of that top surface of this 5 millimeter section. So I need to raise this up to where the top of the this holder will be. So if I click in the middle, and then I believe if we go to more and then move and rotate, I should be able to drag it up, and I can select exactly 10 millimeters. So that's now sits 10 millimeters above the flat surface, top surface of that shape there. Now if we hit exit sketch, I want to join this new drawn surface flat up to the surface here. So I'm just going to select this one, and then I'm going to select this one. And with this, what we can do now is go over to the side. If it's not in the selection here, it'll be in more, is loft. If you hit loft, it's basically going to merge that surface all the way down to the surface underneath. And this could be a different shape. So say if at the bottom of our stamp was rectangular or square, it would nicely merge this circle steadily down into the square shape. This is exactly what I need, so I'm just going to hit deselect all. Because the nature of how we've designed this bottom section first and then this top section second, it's actually seeing this as two separate bodies. So we want to combine these two. In Shapr, it's called union. So in tools, there is union just here. Click union, and then you can select both bodies. When you select both bodies and hit done, now it sees that as just one body. If I double click on this, yeah, you'll see it's now seeing it as one body. I can still see that the top circle sketch is still visible. So if I hit items, I can see on here I've got my main body and the sketch. So the sketch I can just use the eyeball tool to hide and hit items again, and now I've not got any extra sketches blocking my view. With regards to my design, I know that I don't actually have a flat diagonal surface here. It is more of a sweeped radius. So I'm going to show you how to get that in this case, a radius of 12 millimeters just in this section here. So if I click onto the side profile, and on this side it's the left side, and hit sketch, the top line and arc would normally draw a flat line, only until you shake, and actually then will turn it into an arc. So if I just undo that and start my line just on this top surface and then shake, and now come down to this surface here, you can see it's actually in this case a very subtle radius. But here, if I actually type in my radius of 12, I can now see that radius has been put in between my 2 points of my shape. So for this now, I'm going to draw a straight line all the way up to there and a line across to make a solid shape. And you can see that shape is sitting there just in the center. It's cutting into the shape that I've already created, the volume. And I'm going to show you now how to subtract this shape from the rest of this volume. First thing we need to do with regards to this shape is revolve it around that y-axis. So I'm going to select the shape, I may double click on it, then down in our more settings, we've got revolve. If you hit revolve, because we've already selected that, we all just need now to select that middle y-axis. And you can see it's rotated that shape a whole 360 degrees where it meets back on itself. And I can see it there, that's absolutely fine. So I'm just going to hit done. And now it's created a new body of that shape, but revolved all the way around that access point. At the moment, that is not what we want. We basically need to subtract this shape from the body underneath. So the way we do that is if we hit tools and find subtract. So the first thing subtract is going to get you to do is to select the original that you want to keep. So I know I could select this top middle section or this bottom rim, and it should select that body underneath. Now it's basically getting you to click on the volume that you would, or the body that you would like to subtract. So I know it's going to be this side. So it's hard to see at the moment, but this light green section, you can see what would be left if we subtract that section. That's exactly what we need. So I'm just going to hit done. And there we go. You can see you've got that nice 12 millimeter radius along this edge, exactly to my drawings that I've done in 2D design. Obviously the sketch of that little shape is still there, so if I ever need to hide that, you can hit items, find the sketch and just hide it that way. So the body is how we want it, but now it's just missing that middle central column and the void for the nut and bolt. So the way we're going to do that is create the shape next to the piece, and then we're going to do the same kind of subtraction method to then subtract it from this main body. So what I'm going to do is just go to my top view, and just to the side I'm going to hit sketch and I'm going to hit circle. So the cylinder that's going to accept the actual bolt part of the handle is going to be 6.5 millimeters diameter. So for this 6.5, hit OK, and now we've got that circle just there. Hit exit sketching, and then we need to extrude that exactly 13 millimeters. So I'm going to hit that main body, start extruding it up, click in there and go 13. Perfect, okay. And now I'm going to hit deselect all. I'm going to go back to my top view. And I'm going to basically draw the hexagon of the nut. So go down to sketch again. I'll go to more, polygon. If you haven't got hexagon selected there, if you click on the polygon again, you can select between triangle, pentagon, hexagon, octagon. So we need hexagon. And we're going to drag from the middle point all the way down. And making sure that we go completely vertical, and it's not twisting, that's it. And then I can hit the radius, and for this, the nut size would be 6 millimeters for the diameter, but because this is a void where we want to easily place one of the nuts inside, I would suggest 6.2 millimeters and hit OK. Brilliant. And if we zoom out, you can see it's on the bottom plane there. And double clicking inside the mass, we want to extrude up. And the size that we need to go up is 5 millimeters. There we go. And you can see that we've got a nice nut shape on this main cylinder. The final position of the nut actually isn't along the bottom edge. It's actually going to be 5 millimeters from this top surface. So what we could do is zoom in on the side here, double click on the position. It's automatically selected the move and rotate, so I'm basically going to move it all the way up to this top surface. Just making sure there's exactly 8. We could have typed in 8 there as well. And this is a good now point where we know exactly a sort of datum point from the top. We know exactly to go down 5 millimeters from here. So double click on the space again, and then we're just going to move down 5. But this time I'm going to type it in. So it's -5 in this case. Brilliant. So we know this main top surface of the nut is now 5 millimeters from the top of the cylinder, and then we know the bolt's 5 millimeters, which is 10 altogether, and then we know that bottom section is 3, so that's the 13 millimeters, which is the size of the height of the void that we need to make. So if I hit deselect all, this shape now is still going to read as 2 bodies. So as we did before, where we create a union, we need to union these 2 together. So hitting tools, union, clicking the 2 bodies, and then hitting done. Now this is one lovely main body, not made up of 2 separate parts. So to get this void body in the right position to the body we created earlier, we could manually select it and drag it into place. But there are many tools in Shaper which allow us to do that automatically. So for this one, I'm just going to select that top surface. And then on the left here, there's a setting called Align that's appeared. So if I go to Align, and it's going to align the center point of that surface to wherever I pick. So if I go and now select the middle of this one, it has put it directly in place. But what it's done is it's actually flipped it over. So that surface that I did select is now touching that surface and everything is above. That might not have happened automatically on other iPads. Maybe it's a setting that I've got, but it's flipped it automatically. But there is a little icon just below the axis arrows just here that if you click it, then it's going to flip it into the right position inside of that main body that we created earlier on. So if it ever looks a little bit funny and it looks like it's flipped, just hit that little icon and it'll basically reorientate it into the right place. Then you hit done, and we know now that that shape is inside that first body that we created earlier on. So what's left to remove that void shape is to do the subtraction method that we did before. So if we hit tools and subtract, so it said before, select the item first that you want to keep. So we're going to select that outer body because we know we want to keep that one. And the one that we want to subtract is that middle cylinder that we've made there. So if I hit there, you can just see what the void would look like inside. I'm happy with that, so I'm going to hit done. And now if you do peek through that top hole, you'll see that it's cut away the void for the nut and the bolt that we've just created. There are ways to get a better view of this, where you can make a section view, so you can do a cross section. To set that up, you need to create something that's called a plane or a construction plane. So for this one, I'm going to show you how to do that. You hit add, and you can see there that there's a construction plane. You get to select which axis you want it on. So I'm going to select this back one and hit next and hit done. And in the items section up here, I can see now that there's a plane that's right here. So you can select the plane, and with it selected, you can now hit the selection mode on. And I always find it a bit irritating to see the plane still there. So I'm just going to hide that plane and hit done and hit deselect. And now you can see all our measurements to our diagram should be nice and accurate with this 3D model. So we've got a nice deep section of 5mm, the 5mm hex bolt that's in there, leaving a 3mm recess just at the bottom there. And if you ever wanted to turn off the section view, you can just hit it again, and then it all comes back to normal. There's obviously things you can do to this still, where you could select an outer ring and then make a nice curved radius or even a chamfer on it. It all depends what your design is. From the design that you can see at the start of this video, I didn't have any radius or a chamfer there, so I'm just going to hit 0 on that one. So I'm going to drag this out the way, just so I can now in real time show you a square version and show you what that would look like. So I'm going to hit to my top view. So I'm going to hit rectangle. The rectangle is going to go from the center point, so I'm just going to cut the center. And I'm going to go 40 by 20, I think. That's good. Let's double check that's 40. Yeah, that's good. I'm going to extrude that. Extrude that by 5. That's good. Create the top circle, which I know is going to be 24. That's good. I'm going to select that. Hit move and rotate, and I'm going to move that up the extra 10 mils that we need. And then I'm going to loft those two together. I quite like that shape. That's quite an interesting shape. Hit deselect. And then create the void that we need to. So for this, I'm going to go to 6.5mm. Extrude that up to the 13. That's right. This time it might be even easier if I select that face first and to draw the hex onto it. So for this one, 6.2. So now you can see it's actually sat on the top of the piece rather I did it from the bottom before. So for this one, I'm going to extrude to the 5 mils. That's great. And I'm going to move that down 5. That's nice and quick. And then union the two together. I'll just hide any sketches that I've got. Select another line. So it's flipped it, flip it back, hit done, then subtract that from that. Brilliant, and hopefully I can still use my cross section, but I may need to select the plane again. So there you have a square-based stamp body with the same recess in. And if I just show the two together, your design may vary, but I would definitely keep the base to a max of 40mm on one axis. So now we're ready to take one of these pieces and save it as a file that we can actually send to print on a 3D printer. For that, we'll need to put it onto the desktop computer and put it through a slicing software. At the moment, we're using Cura, but when this video comes out, we may also be using Bambu Lab Studio. They're very, very similar. It's just a way of basically converting this file into a file which the 3D printer can print from. So for this demo, I'm just going to delete the square one because I don't need it anymore. So I'm just going to hit delete. Now we've got this shape here, I'm going to save it, and I'm going to show you how to save it or export it in this case. So you go down to export to, and then the top one just says export. Then with here, you've got loads of different files that you can save it to. The two main ones that I would use to take to a slicer software is an STL file or the 3MF file in this case, but STL is absolutely fine. Making sure high resolution's sorted. Don't really need to change any of these settings for this case, and hit export. It should save it into a folder of your choice. So in this case, it would save it into this folder. Click down here and rename it at your will, and then hit save. We may get you to email that file to a member of staff so we can get it onto the Slicer software computer, but your teacher will be able to tell you the best route for that. So now that's saved, let's go over to the PC and show you the Slicer software. So I'm on the desktop computer now, and I've opened up Cura, which is a slicer software made by a particular manufacturer of 3D printers called Ultimaker. It's pretty standard in the industry. Cura is good for a lot of different 3D printers, and that's the one I'm going to just show you today. Just a little bit of what it's actually doing. So the first thing that I'm going to do is find the file and open it up in the software. So I'm going to go up to File, Open Files, find where I've saved the file. Here it is, Stamp Body, and hit Open. And now you can see in the middle of this big square, our little shape is now living. This square is set up as the bed on the 3D printer. So if I zoom in a little bit, we can have a look around and we can see it looks very similar to how we left it in Shaper, but it's now plonked itself dead center on the build plate. So for those that don't really know what a 3D printer is doing, if you imagine a glorified type glue gun that's able to move on 3 different axes, what it's doing is basically it's going to split a 3D body up into lots and lots of lines, so lots and lots of layers. So to create the layers, that's what Cura or a bit of slicing software is for. There's lots and lots and lots of different settings that you can go into, and you can get really granular with what type of 3D printer you've got, from layer lines to fill patterns to different adhering methods to temperatures, speeds. there's a lot, and it can sometimes be too much information to change. Sometimes it's always good to see what the software will actually give you as an automated setting. So you can say set as a standard resolution, standard quality up to like super fine quality. You can change a few speeds, but other than that, I wouldn't really change too much. The software and how machines are calibrated these days are really of a high quality, so you shouldn't really get into any problems with the settings that they've got. For the printers that we've got in school, I've created a few different presets for different size nozzles and different speeds. So my standard 50 millimeters a second speed with a 0.4 nozzle pretty much will give you good results every time. So with that now selected, I'm going to hit slice, and slice is going to now split this body up into lots and lots of layers. And over here you can see what my layer height's going to be. This one's set to 0.12 millimeters. So hit slice. And at first it doesn't look like it's done anything, but when you hit preview, you can then start seeing it in a lot more detail. And I'm going to try and show you that a bit more close up. So here you can actually see every single path that the 3D printer is going to take and basically print a little bit of the PLA plastic. At the moment you can see all the layers there from top to bottom, but with this little slider to the side I can actually go through every layer that it's going to do, right up to the base layers right at the start. So this is a really good indication of what the printer's going to do in every layer. And I can see the void there. I can see it's going to be nice and clean print, nothing too scary to look at that I know they'll mess up with the printer. I'm just going to check those top layers that I've set. Yeah, that's looking really good. The number that is found just on the top of this slider indicates how many layers are needed to create this piece. So it's actually 125 layers in total, which is a relatively small piece, so that isn't very many. If you was doing a large piece over 30 centimeters tall, you can imagine the high numbers you'll be dealing with and the very long time it would take to print. So with these settings included, it's actually thrown up some information for me here. So I know at these speeds on this printer and at this quality, the print's going to take 1 hour and 1 minute. And down here, because I've told it what filament we're using and the price of per meter of the material, I know that we're going to use 6 grams of filament. It's going to use 2.01 meters of filament for this, and that comes to a total of 10p in price. So this is a good way of if you're producing pieces, a good way of checking stock levels and even pricing up little jobs as well. So if we was happy with that and everything looked as it should do, we could instantly save it to the disk. In this case it's a micro SD card, and take it to the 3D printer, and we would be done. It would print this whole section off, including this brim, which is easily removed afterwards. This brim, I forgot to say, is just for adhesion to the bed. For this sort of design, this is a good amount just to make sure it's stuck to that bed and it's not going to come off mid-print, say after 30 minutes, and waste a lot of filament and time. So yeah, we'd hit save to disk and we'd be all ready to go. But in this case, we actually want to drop that 6 or M6 nut into that recess. So we kind of need the machine to put a pause in at that stage. So what I'm going to do is I'm going to work out, if I use my arrow keys, I can go up and down gently through those layers and I want to find that first layer that's going to go on top of the nut. So I can see that that's going to be layer 84. So in the G code, which is obviously all the data and the code generated that's going to control the print head and well, the whole printer, we can basically edit the G code to put a pause in at that point. So 84. So in extensions at the top, I can go to post processing and modify G code. And then I'm going to add a script. And from here, you can create lots of different things. But if I scroll down, there should be one that says pause at height. So if I click that one, and you can either get it to pause at a height, so particular millimeter, or at a layer number. So we need to now pause it at the layer that we found, which in this case is 84. So we're going to go to 84 there. Just checking the other settings, shouldn't really need to change them. One thing I do like it to do is in most printers internally there is a speaker which can display a noise. So I like it to beep at pause, and I like it to be a nice long beep. So at the moment it's going to do it for, I believe, 1,000 milliseconds, but I'll do it to 6,000. Like it to make a nice long noise. If I'm outside of the of where the machine is, say in another workshop, I like to be able to hear it. And I'm just going to check everything else. Yeah, that's good. I'm going to hit close. Now we've added that extra bit of script into the G code, it needs to be sliced again. So I'm just going to hit slice again. Now it has that bit of code adapted into it. So it hasn't affected the time at all. Obviously, it will affect the time if I don't go to the print bed, say within like 5-10 minutes or something. But I try and do it as quickly as possible to drop that bolt in, and then I hit resume on the printer, and it would then carry on with the print and print the rest. So I'm happy with this. So I hit save to disk, save it to the SD card, and I can set it up on the printer. It's all ready to go. So that should show you basically how to design in Shaper right up to making it all nice and sliced to go onto the 3D printer. Thank you.